Good day, students. In this clip, we're going to be going over how to graph transform sine and cosine functions. Okay, so the instructions for the examples as follows. Says for the given functions, we have to find the properties of the function, a window, and graph two periods of the function. For number one, we're going to be graphing the function f of x equals 2 pi sine pi times x minus 1 plus pi. Okay, so let's go ahead and write down the properties first. That's what we're going to use to generate the graph of our function. So properties. Alright, so the properties are as follows. First thing we want to find is the new origin. The new origin is given by hk. Okay, hk. So what is hk in this equation that we have right here? Well, let's go ahead and write down the general form of the equation that's going to help us find out what h and k are. So we have f of x is equal to a sine b x minus h plus k. All right, so we can clearly see that h goes with the x's, k is the number that's been added to this quantity, and a is the coefficient of the sign, and b is what comes before the parentheses. All right, so one thing you want to note is that the variable with the minus next to it, that tells you that anytime you're looking for the x coordinate of your new origin, you have to do the opposite. Okay, so in this case, h is going to be the opposite of -1, which is +1. And then k, you do not do the opposite. You just take the number that's been added on to it, and then that's pi. So there goes your new origin. The new origin helps us determine the phase and vertical shift. So let's start with the phase shift. The phase shift is the shift of the graph in the x direction or horizontally. The phase shift is the value of h. In this problem, h is equal to 1. Since it's positive, that means we're going in the direction of the positive x-axis, which is to the right. The vertical shift is k, and that's pi, and this is in the direction of the y-axis, and since it's positive, that means we're going to be going up. All right. Next property we need is the amplitude. The amplitude is computed by finding the value of the absolute value of a. Okay, in this problem, the absolute value of a is 2 pi, so the absolute value of a is going to be the absolute value of 2 pi. Absolute value of 2 pi is 2 pi, and that also goes in the direction of the y-axis, so that's up and down from the new origin. Next property we need is the frequency. You can find the frequency by computing the value of 2 pi over b. Okay, so that's going to be 2 pi over b. B is pi, so we have 2 pi over pi, and 2 pi over pi is equal to 2. Okay, this also helps us calibrate. Well, actually, this is not the frequency. This is the period. This is the period. Sorry about that. Looking for the period here. Period. So the period is 2 pi over b. Okay, so this helps us calculate how to calibrate our x-axis. Now, if you think about a period is a full cycle, and you can break a full cycle into 4 quadrants, okay? So when I'm graphing, I'm going to let 4 ticks be equal to 2. 4 ticks equals a period. This helps you generate your graph nicely with taking advantage of the symmetric nature of the graph, okay? All right, we have the period, now the frequency. The frequency is the period per unit time, is the reciprocal of the period of b over 2 pi. And since the period is 2, the frequency is going to be 1/2. Okay? Now, next thing we're going to do is set up the window. The window will help us to draw our graph in such a way that it captures the 2 periods and the amplitude of our graph. So to set up the window, we're going to write down the center first, the new origin, which is 1 pi. And then we're going to be going up and down and side to side. All right, so before we set up our window, let's just put some things down to help guide our construction of the window. You want to remember that we have your x-axis going side to side. Okay, that's your x-axis. This is a positive x and this is a negative x, and then you have your y-axis going up and down. Okay, so this is your y-axis, that's a positive and that's a negative. So for our window, we're going to be going up and down. This is our x coordinate right here. This is the x, and this is the y. We're going to be going up and down by the amplitude. So up to the maximum, and then down to the minimum using the amplitude, and then we're going to graph one period to the right and one period to the left. That's what the problem asks us to do. So let's go ahead and put in the measure. So for our amplitude is 2 pi. So going up, we're going to add 2 pi. And then going down, we're going to subtract 2 pi. Okay? And then for our, let's go ahead and calculate what that is. So pi plus 2 pi is 3 pi. So our maximum displacement is going to be 3 pi. Pi minus 2 pi is negative pi. So that's going to be our minimum displacement from the center. One period to the right, we're going to add one period, which is 2. So plus 2. And then one period to the left, we'll subtract 2. Okay? So 1 plus 2 will give us 3. And then 1 minus 2 will give us negative 1. Alright, so there goes our window for our graph. We go as high as 3 pi as low as negative pi. We're going to go to the right as far as 3, and then to the left as far as negative 1. Alright, now let's go ahead and set up our coordinate system. This window is basically going to guide us. So let's see. Our origin is in the first quadrant. Our new origin is the first quadrant. If you look at the x's, this number is bigger than this number, so we're going to shift our x-axis to the left a little bit. I mean our y-axis to the left. And then this number is much bigger than that, so that pushes our x-axis down. Okay. All right. Now let's calibrate our x-axis. Let's call this negative pi. And then going up, this would be positive pi. And then this would be 2 pi. And then this would be 3 pi. The reason why we're going by pi is if you look at your y coordinates, they are all in terms of pi, so you just follow that pattern. Okay? So there goes your y-axis. Now let's graph our x-axis. Now for our x-axis, 4 ticks is equal to 2, so we have to use that. So we're going to go 1, 2, 3, 4. That's 2. Okay? And then going in the other direction, 1, 2, 3, 4. That's negative 2. We need to graph negative 1 and 3. Now let's see, where is 3 at? Let's do another, say 1, 2. Since 4 tick marks is equal to 2, then 2 tick marks is going to be 1 unit. Okay? So this right here is going to be positive 1, and this right here will be negative 1, right at the center. Now where is 3 going to be? Since 4 tick marks is 1 unit, 4 tick marks is 2 units, then 2 tick marks will be 1 unit. So we need 1, 2 will take us to 3. If we did another 3, 4, that will take us to 4. Okay? So we're simply going from negative 1 all the way to 3. So these are the numbers we have. Let's see, negative 1, 3. We have negative 1, 3 on the x-axis. And then for our y-axis, we have negative pi, 3 pi, negative pi, 3 pi. Okay, now let's graph the new origin, 1 and pi. So we have 1 and pi as the center. Now let's graph our x-axis, our new x-axis through our new origin. That's a new x-axis right there. Let's graph our new y-axis. This is our new y-axis. We're going to act as though the old axes are no longer relevant. Okay, all we care about now is just our new axis. So there goes our new x, our new y. Now we're going to graph our maximum displacement from the center. There's 2 pi units from the center. That takes us to 3 pi. So there goes our maximum. And then our minimum is negative pi right there. So we're just graphing one period of the sine. Or what are we graphing here? Let me see what we're graphing. Sine, okay. We're graphing two periods of the sine, one to the right and one to the left. So we remember what our trig functions look like. Remember that the sine function is like an S going up when positive, down when negative, and then our cosine is like a cup. Okay, so I want to keep those in mind. Now, since we're graphing the S, let's put in the points. We're going to start from our new origin. One tick mark to the max, another tick mark to the center, one tick mark to the minimum, and another tick mark right back to the center. So you see that S pattern being formed there. Okay? That's one complete period to the right and one period to the left, one tick mark to the min, one tick mark to the center, one tick mark to the maximum, and another tick mark right back to the center. And this pattern just continues forever. Okay? In this problem, we asked to just do 2 periods, and that's sufficient. So let's connect our dots, keeping in mind the concavity of this function. So concave down to the max. Let me do that again. So this portion will be concave down. And then concave up to the minimum. And then this is concave down to the center. And concave up to the minimum. Concave up to the center. It just goes on. And then this is concave up to the minimum, concave down to the center, and this is concave down to the minimum. Part of my graph, this is difficult with this device that I'm using. Anyway, so there basically goes your sine function, graphing 2 periods with the specified window. Okay, so now let's go ahead and take a look at the next problem. So for number 2, we have an inequality situation. So for number 2, we have f of x is greater than -3 cosine 2 pi x plus 1 plus 1. Okay, so we're going to do exactly the same thing we did before here. All right, to start off, we're going to find the properties of our graph. So the properties. We're going to start with the new origin. New origin is HK. All right, let's label this again so we can know what's going on. So we have A cosine. This is a general form, B times x minus h plus k. Okay? So what we're going to do now is, actually this is the standard form. What we're going to do now is find h and k. We can clearly see that h is -1 and k is +1. Okay? So there goes h and k. All right, now this tells us a phase shift. Let's go ahead and write that down. Phase shift is h. It's -1. Since it's negative, that means we're going to be going left. Vertical shift, movement in the x direction. Vertical shift is k, which is equal to +1, which means we're going to be going up. Okay? Next thing we have to find is the amplitude. The amplitude is determined by computing the value of the absolute value of A. In this case, we're going to be looking for the absolute value. You can see A is -3 of -3. That is equal to 3. And you're going to be going up and down. All right, next thing we have to find is the period. The period is 2 pi over B. We can clearly see that B is 2 pi here. So the period is going to be 2 pi over 2 pi. 2 pi over 2 pi is 1. That tells me how to calibrate my x-axis. It tells me that 4 ticks is equal to 1. Okay? All right. Last property is the frequency. The frequency is going to be the reciprocal of the period, b over 2 pi, which is equal to 1 over 1, and then that's just 1. All right, let's set up the window for this graph. Let's see how I did this one. Okay. So the window is as follows. window. Graph the new origin first. Our new origin is -1, comma 1. Alright, so up and down, we're going to add the amplitude, and down, and then the period side to side. So we can know exactly how to capture the key parts of our graph. So amplitude is 3, so we're going to add 3 and subtract 3. And then for the period, we're going to add 1 and subtract 1. Okay? All right, let's go ahead and carry out the computations here to see what our window is. So -1 plus 3 is 4, and then 1 minus 3 is -2. That's our max and min. One period to the right, 1 plus 1 is going to take us to 2. One period to the left, -1. Oh, I think I made a mistake here. I added it to the wrong coordinate. So one period to the right is going to be -1 plus 1, which is 0. And then one period to the left is -1 minus 1, which is -2. All right, so there goes our window. Another thing that we have to note here is our graph is not a line. It's going to have some effects to it. Why do we have some effects to our line here? Well, we have some effects because it's an inequality. Okay, so the inequality we have is the greater than inequality. So since it's greater than, what does that mean? It means that we're going to have a broken line. The line is broken because there's no line of inclusion underneath our inequality, and we're going to shade up. Okay, greater means you shade up, less than means you shade the bottom. So these are the effects we're going to be applying to our resulting graph. Okay, so let's go ahead and draw the graph first. Set up a coordinate system. -1, 1 is in quadrant 2. Let's see how to set this up. This is a little bit bigger than this, so that means that we need to shift our x-axis lower. And let's look here. Oh, it's all negative, so 0 to -2, so that means we're going to shift our y-axis to the right as much as possible because there isn't any positive x values in our graph. Okay, so there we have it. Now let's go ahead and calibrate our axis. To start with the x-axis, we're going to go down to -2, so 1, 2, -2, and then up we're going to go all the way to 4, 1, 2, 3, 4. Okay, so from -2 all the way to 4. And then we have the x-axis calibration. 4 ticks is equal to 1. Let's go ahead and do that. 1, 2, 3, 4. Since we're going to the left side, this would be -1. And then we have to go as far as -2, so we'll do it again. 1, 2, 3, 4. This is -2. Okay? All right, let's go ahead and graph our new origin. Our new origin is -1, 1. This is 1 right here. So draw our x-axis. Our new x-axis goes right through the new origin like that. Horizontal line through the new origin, and our y-axis is a vertical line through the new origin. Our maximum displacement is 3 units up from the center, which takes us all the way up to 4. Minimum displacement is 3 units from the center, which takes us to -2. All right, so we're graphing what are we graphing again? Cosine. So remember the orientation of our cosine curve. Our cosine function is like a cup, right? So let's review that again. Sine. If sine is positive, you're going to have an S like this. If the sine were negative, you're going to have an S going in the other orientation like that. Okay? Cosine. If cosine is positive, you're going to have a cup like this. And then if the cosine were negative, you have a cup that's inverted. So please pay attention to the sign of your function before you plot the points. This has a negative in front of the cosine, so our cup is going to be inverted. What does that mean? It means that instead of starting from the max, our graph has been reflected vertically, so we're going to be starting from the minimum this time, okay? So from our new origin, we're gonna start from our minimum, one tick mark over center, one tick mark over max, and then back to the center, and then min. So there goes our cup, inverted cup for cosine. And then going to the left, one tick mark over center, one tick mark to the max, one tick mark back to the center, one tick mark back to the mean. Now you have to be careful. Remember, our old coordinate system, our old x and y, do not count anymore. Okay, we have a new coordinate system that we are using. So when you're graphing your points, please avoid plotting points on your new x-axis, on your old x-axis. Okay, you just graph it on your new coordinate system because the whole thing has been shifted. Okay, so there goes your cosine, two periods of a cosine function. So let's connect the dots. So this is concave up to the center. I'm going to try my best here. And then concave down to the max. Okay. And then we have concave down to the center. It's a little bit off. Let's try that again. Concave down to the center. And then concave up to the min. Concave up to the min, like that. And then concave down to the minimum. Concave up to the min, concave down to the center, concave down to the center again, and then concave up like that. Okay, doesn't look too good. My graph is a little bit big, so it's hard to really draw it properly. So there goes just a sketch of our trig function. Now, what we want to note here is that our line is supposed to be broken. So let's go ahead and break it. We're going to apply the effects here. Okay, so it's supposed to be a broken line, and we're supposed to shade upwards. So let's go ahead and break it. You can just simply erase portions of your graph. If you're doing a pencil, so it's broken, just break it. Break it, break it, break it. Okay, the reason why it's broken again is because we have an inequality. That means that we're going to have to exclude the line because the inequality does not have the inclusion bar underneath the inequality. Okay, so you have a broken line like that. All right, so now that we've broken the line, where are we going to shade? Since it's greater than, we're going to be shading up. So let's go ahead and shade it. So we're going to shade the top like that. Using concentric lines, you don't have to do too much. So you have to stay above, strictly above this function right here. So shade the top like that. Like that. Shade. Okay, so that's the graph of our translated inequality for our trig function cosine. All right, so that's that. Thanks so much for taking the time to watch this presentation. You can feel free to subscribe to our channel for other cool clips such as this. More clips can be found on mathcodeserve.com. Thanks again for watching and have a wonderful day.